Guys, today we're talking key features of graphs. So we're going to be talking about a lot of vocabulary. And so if you have a printer, awesome. You might want to print these out. Otherwise, just try to maybe draw some little coordinate planes on your piece of paper so that you can draw the graphs on there. And then on the back side, we're going to have these actual graphs should probably look familiar because we've used them before. So we're going to use them again to continue kind of defining some words on them and key features and stuff like that. So anyways, this is a coordinate plane, okay? And so we are going to label this. And so this is our x-axis. This is our y-axis. Where the x-axis and the y-axis meet is known as the origin, and the location of the origin is at 0, 0. Okay, and then the coordinate plane is split into 4 quadrants, and the top right is quadrant 1, and quadrant 1 is made up of positive x values and positive y values. And then quadrant 2 goes counterclockwise, is top left, and that has negative x values and positive y values. Quadrant 3 is bottom left. That's negative x and negative y. And then quadrant 4 is bottom right, which is positive x and negative y. Sorry, slight technical difficulty, so it's going to look a little funny there. Next 2 words are discrete and continuous, and we've actually talked about these already before. But discrete, remember, is when the points are not connected. So we could have 2 graphs that looked identical with each other, okay? And so I could have this graph, okay? And notice I am not connecting my dots. That is a discrete graph, okay? A continuous graph is when the points are connected, okay? So I can do this exact same thing. Okay, and I was trying to find a ruler to connect them, but of course, my kid's still in it. And see how I've connected them? That is now continuous. And it's really important to make sure that you understand that just because it says continuous, that doesn't mean that the graph does not have to continue forever. Okay, and that's a common misconception is some people think that continuous means that it has like the arrows on both sides, and it could, but that doesn't mean that it is continuous. Okay, so you don't have to have arrows on both sides in order for it to be continuous. It just means that when you have the dots, that they are connected, that you are including all the points in between the graph as well. Okay. So now we're going to look at some key features on a graph. Okay, so I'm going to take, and I'm going to just kind of draw a random graph on here. So it doesn't need to be perfect. Okay. So just draw anything. Okay. Just trying to have it have some highs, a little bit of a low, and then a real big low, something like that. Okay. So using this, we're going to define some words over here. So the y-intercept is where the graph crosses the y-axis. And it's always written as 0, y, because the y-axis is when x is equal to 0. So on this graph, the y-axis is, or not the y-axis, I'm sorry, the y-intercept would be right there. That's where the graph is touching the y-axis. The x-intercept is where the graph crosses the x-axis. And that one is written as x, 0, because it's when y is equal to 0. So on this graph, it actually happens quite a few times. There's one, there's another, there's another, there's another. So that one, that's an x-intercept, that's an x-intercept, that's an x-intercept. So there's 4 x-intercepts on this particular graph. A maximum is the highest point on the graph. Okay? So if it says where, so where is the maximum, you would put x, y. Okay? Otherwise, it's just y. Like, what is the maximum? Then you would just put the y value, because that's the maximum height is just the y. But if it's saying where, then where is always a location. Okay. And so for this one, let's see, looks like that is our maximum. Our minimum is the lowest point on the graph. And this is the same idea, where if it says where, you put x, y, otherwise you just say y. Like, what is the maximum? You give the y value. If it says where, you give the location. So this is my minimum. All right, and then independent and dependent variable. Again, we talked about this in our lesson before. Okay, independent variable is the input or the x value. Okay, and those, and the independent variable, it's made up of the domain. All of those things are made up of the domains because they're the x values. The dependent variable is the output or the y values, and it's made up of the range. Okay, so now we're going to look at some more examples, and we are going to look to find their key features. Okay. Okay, so we will work through the first one together. So we need to determine if it is discrete or continuous. And I would say that since this is not dots, that this is definitely continuous. The y-intercept or intercepts, here's the y-axis. And there is where it's hitting it. So sometimes you may have to estimate it. So the y-intercept, remember, is always written as 0, the y value. And I would say that that's probably at negative 2.5. The x-intercepts or intercepts. Let's see, here's the x-axis. So it hits it here, here, and here. So that would be at 1, 0, 6, 0, and 8, 0. Then we need to find the maximum, so the highest point. And here is our maximum. So the maximum is at 3. Or if it had said, where is the maximum? You would have put the ordered pair of 5, 3. Okay, but 3 is the preferred again. And then the minimum, the lowest is right here. So there's our minimum. And that was at negative 2.5. Or the ordered pair is at 0, negative 2.5. And then just a follow-up question, since we didn't write it. Is this a function? Because we should always keep practicing this. And the answer is yes. And remember that magic sentence, each x value has only one y value. Okay. All right. You guys are going to try the next one with the turtle. So you're going to determine, is it discrete or continuous? What is or are the y-intercepts? What is or are the x-intercepts? What is the maximum? What is the minimum? Go ahead. Okay. So, is it discrete or continuous? You should have said continuous because it's connected. What is the y-intercept? Well, if I go over to the y-axis, which is right here, it's at 0, 0. What is the x-intercept? Here's the x-axis, so right here and right here. So that would be at 0, 0 and at 21, 0. What is the maximum? Well, the highest that it goes is right here. So that's at 120. And what is the minimum that it goes? That's down here at 0. Okay. Just while we're looking at this graph, some good things to also notice, since we are talking about key features, are when is it increasing and when is it decreasing? Okay. So we can write it in words and then we can write it in inequalities. So I'm looking at it and it increases here, right? It's increasing here and then it's increasing here. From here to here, it just was like flat, right? And from here to here, it was flat. And then from here to here, it was decreasing, right? So I can say that it was increasing from 0 to 6. And then again from, what is that, 10 to 13. And then it was decreasing from 15 to 21. So to write that in inequalities, this is the x values, right? So between x is 0 to 6, it was increasing. And again, from 10 to 13. And then it was decreasing when x was between 15 and 21. Okay. All right, you're gonna try this one too. Discrete or continuous, y-intercepts, x-intercepts, maximum, minimum. Go ahead. All right, discrete or continuous. Hopefully you said discrete because these are clearly dots and they are not connected. Y-intercept, here's my y-axis. Are any of the dots on there? Hopefully you said no, so there are none. Here is the x-axis. Are any of the dots on there? No, so there is none. Maximum, which dot is the highest up? And that is going to be this one, and it is at 5. Which dot is the lowest? And that is this one, and that one is at -4. Okay. Last question for you. Is this a function? Hopefully you said no, because x equals 3 has 2 y values. All right, that is our lesson on key features of graphs. See you soon.